students grade with anyone?
I always did that.
You always did what?
Well, I didn't share grades. I just gave you grades sometimes.
Okay, so we are taking the derivative.
Wait, do I stay here?
Yeah, she's going to bring the computer in here. Oh, you are with Ben and Joe Hannah. Okay?
We got Steve right now. Because he always does.
Because you're in trouble.
Yeah.
You can't handle it anymore.
I got the best group of all
I
time.
don't. Why don't I
Best group of all time.
Yeah.
I imagine they both feel the same way. They're pretty excited. All right, we get to be with Shaq. It's A+. We're going to do group quizzes
Hey, I got-
test too.
Oh, seriously?
No.
I got the-
Okay, so we have to do the quotient rule, right? So what do you do?
Low, high.
Low, high. So low is secant of x. The derivative of the high function is
Is that -1 or -1?
minus 1. Secant squared of x. Okay, so that's low d high minus I, which is tangent of x minus 1. D low, what's the derivative of secant?
Secant x times tangent.
Secant x tangent x. Of course,
Yeah.
over the square of what's below. So secant squared of x, right?
Not that far.
Okay. And then I think that because we're going to be doing this in a different way,
Yeah. Like
Basic do this.
school. Yeah.
we better do some simplifying here. Okay? So what is secant of x times secant squared of x?
Did I have to square the whole thing?
I did, secant squared.
Do I have to square that, though? Secant squared of x is squared.
Yeah.
No, just secant, it's just, that's like the square. You want me to write it like this?
Oh, never mind. I thought it was already secant squared of x.
Oh, okay.
Like,
Okay,
like-
so let's simplify. What's secant times secant squared?
It's secant cubed.
Secant cubed. Minus, if I distribute this, tangent times secant tangent is going to be what? Secant x tangent squared x, okay? And then you have to be careful with this. This minus carries through to make that a plus, okay? And then I'm going to go plus 1 times secant tangent, which is just going to be plus secant x tangent x. All right?
Why does this secant multiply by tangent squared of x?
Because to get that term, we went this thing times that. So tangent times secant x tangent x is secant tangent squared.
That's not a plus sign.
No, it's not a plus sign. Okay? All right, how do you feel about that? We're not done. This is all over secant squared. Okay, so everybody's got a secant, right? So I can cancel, take away secant from everybody. So I'm going to change this to secant squared. I'm going to cancel that, and change that to plain old secant. Okay? You good with that? I think we might have to keep going. Anybody remember from trig class, this trig identity, secant squared minus tangent squared? Is that 1? Something like that? You know that sine squared plus cosine squared equals 1, right?
Okay.
So how would I get a secant or a tangent out of that? If I tangent is sine over cosine, right? So I'm going to divide everybody by sine squared. Whoops, I'm going to divide everybody by cosine squared. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. And so if I make this match here by subtracting the tangent from both sides, what you said that secant squared minus tangent squared will end up equaling 1. Do you see that?
Hey, I wasn't the one that said that.
Oh, who said it? Did somebody say it?
Yeah, but it wasn't me.
Oh, all right. Anyway, so this secant squared minus tangent squared, we can reduce that whole thing to 1. So this is really 1 plus tangent of x over secant x. All right? Okay?
Yeah.
Don't know why you ever would have trouble with that problem.
That's stupid. It just tangent one. That's the answer?
Well, that's the answer to part A. Okay, you ready for part B? All right. Part B says, hey, let's do this derivative in a different way. Let's take tangent of x minus 1 over secant of x and change it all into cosines and sines, and then take the derivative from there. So what is tangent in terms of cosines and sines?
It's cosine of sine.
Or,
Sine cosine.
some people might say it's sine over cosine.
Well, since it's opposite.
It is opposite day. What is secant? 1 over cosine. So instead of dividing by 1 over cosine, I can multiply by the reciprocal. So I can rewrite this as sine of x over cosine of x minus 1 times 1, oops, not 1 over cosine, cosine over 1, right? So what is sine of x over cosine of x times cosine of x? Sine of x. And then minus 1 times cosine is cosine. So what they're saying is we could have simplified this all the way down to sine of x minus cosine of x first. Did I do that right? And then taken the derivative. Okay? And this is a little bit easier because what's the derivative of sine of x minus cosine of x?
Cosine minus sine.
Cosine of x, but it's negative sine, so it's going to be cosine of x plus sine of x. Okay? Do you see that those two answers are the same? Not really, no. So we have to do a little bit more work. So let's go 1 plus tangent of x over secant of x. So I want to show that 1 plus tangent of x over secant of x equals cosine of x plus sine of x. Doesn't this bring back happy memories of doing trig identities? Yes?
Said nobody.
Okay, so change the 1 plus tangent of x over secant of x. Give me that in all sines and cosines. Okay? So tangent is sine over cosine. And secant is
1 over
1 over
cosine.
cosine. Okay? So just like any other thing, what can I do instead of dividing by 1 over cosine? Multiply by cosine over 1, or just plain old cosine. What's 1 times cosine? Cosine plus sine of x divided by cosine x times cosine of x is
And we got sine.
sine of x, and guess what? They're the same. Okay? Sine of x over cosine of x. That's a C. Can't imagine why you didn't do that one on your own. That's your next quiz right there, that one problem. You need calculus to work with the numbers.
That's everything.
Okay, so now we're going 32. Okay, 32, we are given some values of the function to start with. So if you plug in pi over 3, you get 4. And if you plug in pi over 3 to the derivative, you get negative 2. G of x equals f of x times sine of x. And h of x equals cosine of x divided by f of x. So seriously, who comes up with this stuff? All right, so the first thing we're going to do is we are going to find out what g prime of pi over 3 is. Okay? So what's the derivative of g? F of x.
Is this stack maybe?
Yeah.
Okay, I'll help you figure this out.
First one times the derivative of the second one. So that's cosine of x. Plus, what's that? F prime of x times sine of x, right? So first function, derivative of the second one, derivative of the first function, second one. Yes? Okay. And then now let's plug in pi over 3. So what is f of pi over 3? 4. What is the cosine of pi over 3? Anybody got that one right off the top of their head? Do you got that memorized?
It's 0.5.
0.5? That's handy. What is f prime of pi over 3? -2. And what is the sine of pi over 3?
And it's 0.86.
What'd you say?
.8
Root 3 over 2.
0.2.
Root 3 over 2. Did you? You got the little things there?
I got 0.8.
Okay, so 4 times a half is 2. Over here, obviously the 2's cancel, so it's going to be 2 minus square root of 3. Okay? Final answer, huh?
Look at it and see this yield in
All right, so do you understand the concept of what we're doing there with this problem? So we just took this, and since it was a product, we used the product rule to take the derivative and then plugged in the values. So now can you do part B on your own, where you are taking the derivative of a quotient, and then you're just going to plug in the values? So will you work on that on your own? Okay, so we're going to take this and find the horizontal tangent. So the first step, 95% of the time, is
Find the derivative.
find the derivative. So the derivative is 1 plus 2 cosine of x. Yes?
Yep.
Okay. What does the slope equal when you have a horizontal tangent? 0. So you got to take this and set it equal to 0. Will you do that for me? Right. So you're looking for where the cosine is equal to -1/2. Where's that? What's that? So you can do arc cosine of -1/2 if you want to find one solution. What'd you get? Which is pi over what? 2 pi over 3. So if you think about the cosine graph, it looks something like this. And you're looking for -1/2. So right here is the low point is pi. So this value right here is 2 pi over 3. What's this next value going to be? What?
2 pi.
What?
4 pi.
4 pi over 3, right? Because this is 1 pi, or this is pi over 3 below pi. So this is going to be pi over 3 of what? 3 pi over 3 is pi. Yeah, I don't know why I said that. It's going to be 4 pi over 3 right there. Okay? And then where's the next one of this one going to be? So we have one answer is 2 pi over 3, and then the next one is 4 pi over 3, and then it's a 2 pi cycle, right? So if I add another 6 pi over 3 onto this, then I
You
get,
get 2 pi.
what?
Never mind.
If I add 6 pi over 3 on
You
2 pi
add
over 3,
6 pi over 3.
I get what?
Very simple.
I I get what? 8 pi over 3? And then if I add 6 pi over 3 onto this, I get 10 pi over 3. So what is the pattern for these numbers here? How can we come up with, something over 3 deal? Like to list all of them. We're obviously not going to go forever and ever and ever. What's that?
Straight, etc.
Etc. If I go, let me see if I can remember this. If I go plus pi over 3 here, then that gives me pi, right? If I go minus pi over 3 here, then that also gives me pi. If I go plus pi over 3 here, then that gives me
Something
3 pi, because it would be 9
That's
pi over 3 or 3 pi. If I go minus pi over 3 here, then I also get, nope, if I go minus, I would get 9 pi again, which is 3 pi, okay? So these answers are all the odd pi's, okay? So what that means is, the odd, the way to get an odd number always? If you take any number and double it, you'll always get a even number, right? 3 times 2 is 6, 4 times 2 is 8. If you double it, you get even. So if you want to take an even number and get an odd number, you can add 1 onto it. So if I say 2n plus 1 pi, that will give me all of the odd values of pi. Okay, but then that's not what I want. I want these, so then I have to go plus or minus pi over 3. Should be. So if you take any value of n right now, integer number, and plug it in, you'll get one of these guys right here. Okay? Yeah, that was a lot. So, whatever. You kind of like have a little bit of a handhold on that?
Not really.
Not really. Okay. Well, let's not sweat it too much. Maybe you got something out of it. I don't know. We'll see it again. It'll be fun. All right, 34. Maybe we'll see it again right now. Find the points on the curve. Y equals. Okay, so we're looking for horizontal tangent again. So we start by taking the derivative. Will you do that on your own? That's what you got there. Okay, so everybody get that? Okay, so we want to figure out again where this has horizontal tangents, and we already talked about the derivative equals 0 there. Okay, what has to be true about a fraction for it to equal 0? The only thing that has to be true about a fraction for it to equal 0. The top has to be 0, so we don't really care anything about the bottom at all. Okay, we want the top to be equal to 0. So I'm going to simplify this a little bit. 2 times negative sine is negative 2 sine. Sine of x times negative sine of x is negative sine squared of x. And negative cosine times cosine is negative cosine squared of x. And we want to know where that is 0. All right? Any ideas where to start? Parentheses? What do you mean parentheses? Do you want to change every? Yeah, negative, negative, negative. Can we go plus for the whole thing? Switch them all around. So make this 2 sine of x plus sine squared of x plus cosine squared of x equals 0. Yeah. Big trig identity staring you right in the face. Most important one of all time.
Ben said it.
Ben said what? Sine squared plus cosine squared equals 1. Okay, so really what we're messing with is 2 sine of x plus 1 equals 0. So we're pretty much in the exact same situation as we were with the other one. Subtract 1, divide by 2. We are looking for where the sign of x equals negative 1/2. So here you have another chance to get on board with how do you list all of those solutions. Are you ready? Can be good, Nate. You're going to love it. So once again, let's look at the graph. So this is pi, this is 2 pi, and we want to know where sine is equal to 1/2. So finding the first.
It's negative 1/2.
Is it negative 1/2?
Yeah, subtract 1.
My bad. Okay, so we're looking for there, and we're looking for there. Okay? All we gotta do is find the first one, and then we're home free. What's this one right here?
Minus pi.
It's not pi. Sine of pi is 0. So we know it's not going to be pi, so we're a little bit past pi. Do you have it? No. How do you find it? Arc sine? Uh-huh.
How do you do arc sine?
Second sine of negative 1/2. What is it?
Everyone's like laughing at us. I don't know.
You don't know? Oh, okay.
How do you do?
No, I do it now. Second.
So you go,
Is it the little
Casey?
negative one?
Yeah, you just go second sine of
No, it's like
negative.
inverse. That's the same thing. Large 0.5.
Okay, so that's a bad deal because that one is actually way over here, right? That's this one, because we got a negative answer. So anybody, you have a little chart on your thing, right? So where does sine of x equal negative 1/2? Where is, what value is the answer negative 1/2? You don't have any signs that equal negative 1/2?
We have some pi circle last year.
Oh, you have what all the square roots
It's pi circle last year.
are. Okay. All right, this is a grim day in calculus class. We go to the
Good.
graphs and go to the unit circle. Okay, so, what's that? You add pi to get to that? Is that what you're thinking? Because we're right here and we just need to go shift it, but see, is that, if I add pi, I just get to right here. So take that number that you got on the calculator and add pi, what do you get? Okay, and what is that in terms of pi over something or something? Like 2 pi over 3, 3 pi over 4. It's nothing? Recording. So this is 5 pi over 6 right there. So what's that going to be? Please. 7 pi over 6. Okay? Because if this is a 1/6 of the pi that way, then this one's going to be a 1/6 of the pi that way, right? Okay. So what's this one going to be right there? Nope. Nope. Not even going to be. 11 pi over 6, right? Because 2 pi is really 12 pi over 6. So if I move a 1/6 of a pi that way, then I get 11 pi over 6, okay? So my answers are going to be 7 pi over 6, and then 11 pi over 6, and then I'm going to wrap around, and it's going to happen again 2 pi later. How many 6s are there in 2 pi's? 12. So I have to take this and add 12 pi onto it, so that will give me 19 pi over 6. Add 12 pi onto that, and that'll give me 23 pi over 6. Okay? So my gate, what?
So you're adding, this is your rubber answer.
I'm adding 2 pi each time to loop around.
pi.
Yeah, because this graph will repeat itself every 2 pi. Okay? I know this is a lot, okay? And if there's one person in here that gets this when we're all done, that's a success, all right? Okay, so what I want to do to figure out my formula is I need to figure out what I need to add or subtract to these to get them to be a regular old multiple of pi. So if I subtract pi over 6 from here, I get pi, right? If I add pi over 6 to here, I get 2 pi. If I subtract pi over 6 from here, then I get 3 pi. And if I add pi over 6 onto here, then I will get 4 pi. So this is a nice one because I can take any multiple of pi. So I'm going to call that just plain old n pi. And if I add or subtract pi over 6 from that, then I will get a sign of -1/2. Okay? So if you look it up in the back, I think this is the answer that they give you. They might use a K instead of an N, I'm not sure.
No, it's taking 4 seconds.
What's that?
It would be even.
Oh, it's an even one. Okay. All right. So I know that's crazy, that trig stuff and solving trig equations. And I know you did this with Mr. Helvey last year because when my daughter had the class, she needed a lot of help when we got to that part. You're making the graphs and the K thingies and the, anyway, whatever. All right. Now what?
35.
35. Okay, 35. Okay, so first part, find the velocity and acceleration at time t. Well, they give you the position, right? So how do you find the velocity? First derivative. How do you find the acceleration? They do it.
I already did it.
You.
There you go. There it is.
Can't go there because it's pending. Yeah, we can't go there. Yeah, I'm not
I
happy.
mean,
Okay, for B, it says find the position, velocity, and acceleration at time 2 pi over 3. How do you do that? Plug them in. Tell me when you get one of them. What?
-4 for
This one?
I did the second one first.
This one?
Yeah.
I got another one for me? For this? Negative 6.298?
That's positive.
Oh, positive 6.298?
Actually, 928. That's the other one.
And this one is negative?
6.
Okay. So is it moving to the left or the right? Why? Okay. So you guys just didn't try that one, right?
Did it?
Huh? No. All right, so we have about 9 minutes. All right, we'll do this. Okay, so 36.
Way too much.
You can do a.
Wow.
You can do a. Right?
Velocity acceleration. 19. acceleration
a little
is
bit on Friday.
Why wouldn't you? Why wouldn't you?
Well, I won't be there on Sunday, I have to work.
Oh, so did you go over and do that?
Yeah.
Well, I'm president, so.
Oh. Are grades going?
I don't know.
Can you appoint someone to be
That's
president?
been on top of that.
What's the difference between AP
Yeah, four
calc and
grades.
calculus?
Always put them into calculus, I mean into AP calculus. Yeah.
I suck.
All right, so you got that for 36A,
Oh yeah.
right? Okay, graph the velocity acceleration function. You can do it on your calculator, it's pretty easy to do. Let's do that. So, somebody tell me what the velocity one was? I don't remember that.
-2 sine of x plus 3 cosine
-2 sine of x plus
3 cosine of x.
and what's the other one?
-2 cosine of x minus 3 sine of x.
Okay, did you guys know that your calculator has a, you guys know that your calculator has a zoom trig button on it?
Yeah.
Okay.
Zoom
Zoom
7.
All right.
Found it.
So there is the first one, that's the velocity. And then there is the acceleration. Okay? So you can just, that's on the calculator. Okay, C, when does the mass pass through the equilibrium position for the first time? What will be true about the velocity at the equilibrium position?
0.
No. What? No, it will, the velocity will be 0 when it's being, stretched, right? And it comes to a stop, and then it goes through, and then it comes to a stop, right? So as it passes through that middle point, that's when the velocity will be the greatest. Okay? So what's true about the, let me just get rid of the acceleration function here. What is true about the graph of the velocity function when it's greatest?
It goes through 0.
Yeah, it's going to be this point right here, right? When it's greatest. When the absolute value of it is greatest. It doesn't matter whether it's positive or negative. Does that make sense? Okay. So how do I find this point right here? I could, yeah. I could do better than trace. You could do the max min thing, right? Okay, so I can find the minimum right here. How would I do it using my powers of calculus? That's not calculus.
Yeah.
Yeah. What's true about this point? It's a minimum, and therefore the acceleration will be 0. Okay, the slope of the tangent line is 0. Okay, so we need to once again take this acceleration function and set it equal to 0. Okay, and we will cut this short in the interest of time. To solve this, get them on opposite sides. And then I am going to divide both sides by cosine. And the reason I did that is because sine divided by cosine is tangent. And then I'm going to divide both sides by 3. So the tangent of t needs to equal -2/3. I guess they just want the very first one. So if you just, bless you, second tangent of -2/3, the answer that you get should be our first t value. Please be positive. Okay.
Wait.
So, what's that? Plus pi, from period pi? Sure, add pi onto that, we'll copy it. So whatever answer you got, go plus pi.
So where do you plug
You
the
get what?
2 into?
2.5.
So,
Is that a real thing?
Oh, let's find out. Because we know how to find this, right? So we go second calc minimum let's go, this is 5. So 0. Let's go 5. And let's say that our guess was 2.5. 2.5. So it all works out. Okay, why don't you put the done right here? Not done.
Okay, where'd you plug in the negative 2/3 at?